Hi folks, this is Nat, and this is going to be your video lesson on identifying proportional relationships and using proportions to solve problems. Hopefully by this point, proportions feel like a pretty familiar tool for us in terms of problem solving. We've seen them with pie charts, so figuring out how much out of a 360-degree circle something should be. We've seen them with percentages, so figuring out of 100. And we've seen them most recently with unit rates, which are out of 1. Today, though, we're going to be talking about no particular unit, but how you can generally use proportions and proportional relationships to solve problems. To understand proportional relationships, it really helps to remember ratios. You may have heard about ratios when we talked about unit rates, which take a ratio and reduce one part of the ratio down to 1. But if you don't remember, a ratio is a mathematical pairing of two things that are measured in different units. Let me give you an example. Let's say that the world hot dog eating champion eats 25 hot dogs in 2 minutes. First off, that's an insane amount of hot dogs. But secondly, we can express this idea in a ratio of hot dogs to minutes or minutes to hot dogs. And ratios can be written a couple ways. For example, I could say this ratio is 25 to 2 with a little colon between it, 25 hot dogs to 2 minutes. I could flip it around and call it 2 minutes to 25 hot dogs. It doesn't really make a difference. But the way we're going to be really focusing on writing our ratios is going to be as fractions, because as fractions we can set up proportions and cross multiply. So the ratio I would give would be 25 to 2, 25 hot dogs, keeping in mind our units, really important to know what units we're dealing with 2 minutes, 25 hot dogs in 2 minutes, and that's a ratio. Just like a regular fraction, if it was reducible, I could reduce this. So if it was 24 hot dogs in 2 minutes, I could reduce it to 12 in 1, or if it was, I don't know, 24 hot dogs in 3 minutes, I could reduce it to 8 to 1. But writing it as a fraction is the most important thing for now. We don't actually have to worry too much about whether it's in simplest form. Up to this point, we've primarily thought of setting up a ratio as a way of getting at a unit rate. So again, if we take my 25 hot dogs in 2 minutes ratio, what we've primarily been doing is saying, well, how many hot dogs per minute is that? And saying, well, then it's X hot dogs in 1 minute, and reducing it to, say, 12.5 hot dogs per minute. But we're not going to do that this time. Instead, we're going to think about, well, what other sorts of problems could we solve? Let's say that we're thinking about that ratio, 25 hot dogs in 2 minutes, and we wonder to ourselves, how many could that same guy eat in 5 minutes? Well, up to this point at least, we might have said, well, I can reduce that down to a unit rate and then take that unit rate and figure out how many in 5 minutes. But the cool thing about proportions is I actually don't have to do that. I can take my 25 hot dogs in 2 minutes and set up a proportion to answer the question, how many can this guy eat in 5 minutes? And I might say to myself, well, if he eats 25 hot dogs in 2 minutes, that should be proportional or equal to whatever number of hot dogs he eats in 5 minutes. You're going to notice here, hopefully, when I set this up, that the units, like we've talked about before, match. 25 hot dogs in 2 minutes. And then over here, an unknown number of hot dogs. X is an unknown number of hot dogs because we're asking the question, how many hot dogs? In 5 minutes. So we've got these unit rates that match each other. Or sorry, not unit rates, but units that match each other. And by cross-multiplying and solving this equation we've written, we can answer our question without ever having to reduce the thing down to a unit rate. So we can say 2 times x is 2 x's, and that should be equal to 25 times 5, which is 125. And I'm gonna, because I'm multiplying x by 2, divide both sides by 2. That gets rid of the 2's over here, it leaves the x by itself. And x ends up being 62 and a half. So the answer to our question is that this guy can apparently eat 62 and a half hot dogs in 5 minutes, which is disgusting. Let's look at another kind of word problem example of this. Bill hit 7 out of the 12 shots he took in his last basketball game. At that rate, how many shots would he need to take to make 18? So this is a proportional relationship, and one of the reasons I know that is because I see this phrase right here, at that rate. We're assuming that he's going to consistently make shots at a particular rate. So that from the get-go tells me I'm expecting this, or at least pretending that this is going to be a proportional relationship. So we're going to start with a ratio. The first ratio that I see is that he hit 7 out of 12 shots. So 7 out of 12 shots, that's actually a fraction. But I can start thinking to myself, what do each of these things mean? Well, that's 7 made shots and 12 taken shots. If I want to answer the question, which is how many shots would he need to take to make 18, I'm going to need to recognize what units I have and what units I don't have. So I'm going to stick an equal sign in the middle, and now it's time to make a new ratio. Okay, I want to know how many he would need to take to make 18. So I'm assuming he makes 18. Well, that matches here, that he made 7. Now I want him to make 18, so I'll put that on the top of my fraction. The question is how many shots would he need to take, so the number of shots taken is apparently unknown, and that matches up with this bottom number 12. So I'm going to put maybe a t in here for taken, and I've made my proportion. Again, I didn't have to change that to a percent or a unit rate or anything like that. I can just set it up with the same units in the same place, and I'm ready to cross multiply and solve this thing. So I do 12 times 18, 7 times t, and I'm going to end up with 7t equals 12 times 18, which is 216. And I just need to finish solving. So I multiplied my t by 7. I'll divide both sides by 7 to undo that. I've got my t by itself. T equals 216 divided by 7, which is, if I round, which makes sense here, about 31 shots. And that's the answer to my question. In order for him to make 18 shots, we're going to expect him to need to take about 31 shots. And that's how that whole proportional relationship thing works. I'm going to give you some practice problems in just a second, but probably right now is a good time to do a quick reminder about proper algebra form or proper algebra notation. There's a lot of folks out there who are kind of getting a little sloppy with this stuff, and it's worth kind of going over what it should look like, because the way we set these problems up has a particular meaning. And so if we set it up weird or solve it in ways that are unusual, people won't know what we mean by our work. So let's say that we're doing the same sort of problem. I say 3 to 5 is my ratio, and I want to know, well, what is that? Let's just make up a number. Say 12. And pretend we've set up a proportion that looks like this. The first thing I'm going to point out is this equals sign in the middle. The equal sign in the middle has to go there for two reasons. The first is that sometimes we multiply fractions instead of cross-multiplying. You cross-multiply proportions. You don't cross-multiply, say, with a regular fraction multiplication. So if I don't put that equal sign there, I won't know the relationship between the two fractions we've written. The second thing is that equals sign says that it's a proportional relationship. So again, I'm setting this up so that somebody else looking at it might be able to understand what this means. And in this case, the equal sign tells us it's a proportional relationship. So definitely put the equal sign in the middle. Secondly, when we cross multiply, we say 3m, 3 times m. We never say m3, always 3m. It's just the way people decided to write algebra. There's nothing you can do about it. And we say 5 times 12 is 60, but the other thing we don't forget is, again, we need that equal sign in the middle. Cross multiplication works on the idea that when you multiply opposite numerators and denominators, they are equal to one another, if the fraction is equal, which we're assuming it is. So if you don't put that equal sign in the middle, again, we're not expressing that relationship correctly. More importantly, when you say 3m equals 60 or 60 equals 3m, that's an equation. An equation is something we can solve. If you just say 60 and 3m separately, that's nothing. So again, it's to help people follow your work. It's to show that you understand what it all means. So put the equal sign in the middle. Lastly, and a lot of you make this mistake, you forget what to divide by what. If you do it this way, you'll always know what to divide, because we always divide by what's next to the variable when we cross multiply. So I've got 3 times m, I undo that by dividing by 3. If we show proper notation, we won't forget what to divide by. And I don't care if you show your division with a line under it, like a fraction, or if you show it with a division symbol at this point, so long as you show that you're dividing by the number you multiplied your variable by. And we finish up with just a simple whatever the variable equals. So do make an effort to get back into the habit of using proper algebra notation, proper algebra form. Some of you are doing a great job with that. Some of you need to refocus on it. Make sure you're showing your work the correct way so other people can follow it. And here are your practice problems for the lesson. You need to show your work on these, please. So show how you set these up as a proportion and then solve them using that proper algebra form we just talked about. Good luck.